Okay, so we want to go now we're still in section 5.1, I'm sorry, and we're going to look at section 5.1, part 2, and we're going to look at rule number 3. Now, I will give you rule number 3, very similar to what I did the other 2 rules. I will get you to write out the definition first, and then I'll do some examples. So, this rule is called the quotient rule. Now, in mathematics, what does the word quotient mean? The word quotient means divide. So like if I said, what is the quotient of 28 and 7? If you do 28 over 7, it's 28 divided by 7, which is 4. All right, so this is a dividing rule. So write this down, pause the video when you need to. If we are dividing 2 terms having exponents, their bases must be the same. To divide them, we will keep the base and subtract exponents. Okay. So, write this down right here. A to the m divided by a to the n equal a to the m minus n. Write that down. Now, let me just show you that this rule right here is basically what we just said. If we're dividing 2 terms having exponents, the bases must be the same. If they are, we'll keep the base and we'll subtract the exponents. And it'll be the top one minus the bottom one for right now. I'll talk about that more in just a minute. So the top one minus the bottom one. All right. So let's do this problem right here then. So if I have x to the 8th divided by x to the 2nd equals, if we use the rule, if we're dividing and the bases are the same, we keep the base and we'll subtract the exponents. So x to the 8th divided by x to the 2nd would then be what? X to the 6th. So you don't divide the exponents like you divide numbers. Is 8 divided by 2 4? Yes. But x to the 8th divided by x to the 2nd is not x to the 4th. You keep the base and you subtract your exponents. So this would be x to what then? The 6th. Okay, so write x to the 6th. Now what I want to do, don't write this down. Now what I want to do is show you why it's x to the 6th. If I write out x to the 8th, it's x times 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 x. 8 times. If I write out x squared, x times x. Now remember, with multiplying, you can cancel. So this x goes into this x and leaves 1s. This x goes into that x and leaves a 1. But look at what you're left with. X times x times x times x times x times x. X times itself 6 times. Which is not 6x, by the way. X times itself 6 times, which is x to the 6th power over 1, or just x to the 6th power. So, now I don't want you to write it out that way. I just want you to go straight to the answer. But I just wanted to show you why that rule works the way that it works. Okay, so I'm about to write down some examples. I want you to do like we've done before. First thing I want you to do is pause the video. Make sure you can see them all first. Yes. Okay, pause the video now and write these down. Okay, You should have these written down. So let's look at this. M to the fifth divided by m to the second. If you're dividing and the bases are the same, you keep the base and subtract your exponents. So that's m to the third. And it's really m to the third over 1, but we don't have to write that. X to the ninth over x to the first is x to the eighth. P to the sixth over p to the 0. Now, there's two ways you can say this. 6 minus 0, which is 6. Or you could just say, remember, p to the 0 is 1, and anything divided by 1 is that. Now, p to the 0 is not p to the 1. It's just 1, not p to the first. There's a difference in p to the first and 1. P to the first is a number. Is a letter or a variable. 1 is a number. Okay, right here. X to the 10th, y to the 11th over x to the 6th, y to the 11th. This cancels with this and leaves x to what? The 4th. Y to the 11th cancels with y to the 11th and leaves y to the 0. But y to the 0 is the number 1. So it's not y, it's 1. So the answer here is just x to the 4th. And then on this last one that you copied, now you divide numbers the way you always have. 6 goes into 24, 4. X to the 10 cancels with x to the 10 and leaves no x's. Or you could say 1, but not 1x. Y to the 1, y to the 11s, y to the 10. And z to the 5, z to the 6 leaves z to the 1. You do not have to put that 1 there. So that is the answer. Now, if you will notice on these problems, all of the problems that we've done, the letter with the bigger power was in top. Now, let's look at this right here. Suppose you have x to the 4 over x to the 7. Now, remember, subtraction is not commutative. So if you do 4 minus 7 and you do 7 minus 4, do you get a different answer? Yes, you do. So in this problem, you say, well, Mr. Rayner, you said the one you gave us, you said a to the m over a to the n. You do m minus n, the top minus the bottom. The reason I said it that way is because that's assuming that the bigger one is in top. See, if you do 4 minus 7 right here, what is 4 minus 7? That's negative 3. Now, we're going to discuss that in a few minutes, but let me ask you this question. Up until now, have we discussed negative exponents? No. So, if I do 4 minus 7, I'm going to get a negative exponent, and I'm not ready to discuss that with you yet. So here's what I want you to do for right now. If there's more in the bottom than there are in the top, what you're going to be left with is in the bottom. Let me write it out the long way first. Don't write it out this way. Let me just show you. X to the 4th is x times x times x times x. X to the 7th is x times itself 7 times. Okay, this cancels with this, leaves 1s. The first 4 cancel. Now, does it leave an x and an x and an x? Yes, but look at where it leaves it. In the bottom. So that x to the 3rd is in your denominator, not your numerator. Now, what's left in the numerator? Nothing but 1s. When a 1 is left in the denominator, you don't have to write it. But when a 1 is left, and that's all that's left in the numerator, you must write it. So the answer to this is 1 over x to the 3rd. 1 over x to the 3rd. So, let me just explain it this way then. Here's the easiest way for you to look at it. If there's more in the bottom than there are in the top, just do the bottom minus the top. So 7 minus 4 would be 3. but you have to remember to put it in the bottom. So if there's more in the top, you're going to put your answer in the top. If there's more in the bottom, you're going to put your answer in the bottom. Okay, and again, I'm going to touch on negative exponents in just a minute. So, look at this problem right here. Where's there more at? The top or bottom? Well, there's more in the bottom. How many more? 2 of them. Because 5 minus 3 is 2. So it leaves an x2 in the bottom. So it leaves an understood 1 in the top. Now, if you've had a little bit of algebra before, you say, Mr. Rundle, can I write that x to the negative 2? 2 things. I'm not ready to discuss that. And even if you do, you can't leave your answer with that negative exponent. But I'm not ready to dive off into that just yet. All right, so let's do some problems here where okay, so I'll tell you what, let's do. Pause the video and copy this. Let me make sure you can see it first. Okay, yes, pause the video now and copy this. Okay, you should have this. So, here we go. M to the 9th over M to the 10th, where's there more at? In the bottom. So that would be M to the 1st, or just M. But M to the 10th over M to the 9th, where's there more now? That's M to the 1st in the top. Over 1. You don't have to put the over 1 there. Now, I told you earlier, I would explain to you why anything to the 0 power is 1. I can do that now. If I have x to the 3rd over x to the 3rd. Question before we work this. What is anything divided by itself in math? It's 1. The answer is 1. What's 10 over 10? 1. 50 divided by 50? It's 1. 0.3 divided by 0.3? It's 1. So what's x to the 3rd divided by x to the 3rd? The answer to that is 1. But if you use your exponent rule, keep the base and subtract your exponents, you get x to the 0 here, but that is equivalent to 1. So that's why anything raised to the 0 power is 1, because it's like dividing that by itself. Okay, then on this last one here, 8 over 6, 6 will not go into 8, but 2 goes into both of these. 2 goes into this 4, 2 goes into this 3. x7, x10 leaves x3 on the bottom. y1, y11 will leave y10 on the top. z8 cancels with z8 and leaves z to the 0, which is understood 1. Now notice again, on all these rules I'm doing with you, you don't see an adding or a subtracting sign anywhere in these problems. It's nothing but multiplying and dividing. Okay, to close out this section, I want to do one last rule with you, and it's called the negative exponent rule. Negative exponent rule. Now, what I want to do first is I'm going to uncover the rule and just let you copy the rule, and then I'll explain it. A to the negative n is just 1 over a to the n. You remember the problem a while ago I asked you, or you said, could I write the answer x to the negative 2? And I said you could, but then really the answer has to be 1 over x to the 2 power. So x to the negative 2 is 1 over x to the 2 power. Now there's a whole lot of mathematics I could get in here that you probably don't care to see. So what I'm going to do is I'm not going to be 100% mathematical here, but I'll give you enough as far as to help you along the way, so you'll know, that'll help you get through these problems without just wading off into all the mathematical concepts behind this. So it's just simply this. If you have a base raised to a negative power, the way you deal with that negative, we can never raise something to a negative power. Like if I said, what's 5 to the 2 power? It's 5 times itself twice. Well, what's 5 to the negative 2 power? 5 times itself negative 2 times. You can't do something a negative number of times. And by the way, if 5 to the 2 power is 25, if you're not careful, you'll be real tempted to say 5 to the negative 2 power is negative 25. That is not the case. So what does a negative exponent do? It flips the problem and you carry it to the denominator. And when you do that, the base doesn't change, but the exponent becomes positive. Now, if it was a base raised to a negative power in the denominator, it would flip back up to the numerator. So we will never leave our answer, never leave a negative exponent anywhere in our answer. Okay, so let's go through some of these problems then. So, x to the negative 4 is simply 1 over x to the 4. P to the negative 1 is 1 over p. And you stop the video whenever you need to. Y to the negative 7 is 1 over y to the 7th. Now, be careful right here. 5 to the negative 3. Remember, this negative 3 power, this is 5 times x to the negative 3. This negative 3 power is only on the x, not the 5. So, this is 5. I'm going to put in a few extra steps first. This is 5 times x to the negative 3, which is 5 over 1 times 1 over x to the 3rd, which is 5 over x to the 3rd. Now, you can see, if you look at this, you can see a much quicker way to do this without putting all this in. If it's 5 times x to the negative 3, if it's multiplication, you can just carry that to the denominator. You can do that if it's multiplying. So, what would be a quick way to do 7 times x to the negative 9? It would just be 7 over x to the 9th. Okay? Now, I'm going to put this up. You pause it. And then I will go over these problems. And then there'll be 3 more after this. And by the way, this down here is a B. Okay, so pause the video now and copy these examples. Okay, you should have these examples copied, so let me go over these. Okay, this one up here, 5x to the 5th, y to the negative 8. The y to the negative 8 is just going to go to the bottom. That's just the quickest way to do it. Now, you can put in the other steps like I did a while ago. 8 times this times this. You can carry both of these to the bottom because both of the exponents are negative. Now, if it has a negative exponent in the bottom, you flip it and bring it back to the top. Now, when you bring it back to the top, this 1 is still right here. It's just 1 times that when you bring it to the top. Okay, right here. This one will show you. 3 over x to the negative 7. When you bring that to the top, it becomes 3 times x to the negative 7, not 3 plus x to the negative 7. Same thing here. When you bring this one from the bottom up to the top, it becomes 4a to the 3rd times b to the 6th. And you don't have to put that dot there. Okay, 3 more examples. I'm going to show you these 3. Pause the video, and then I'll go over these. Okay, so pause the video right now and copy this down. Okay, you should have these copied now. Let me show you these. Okay. When I look at this problem, if it has negative exponents in it, I move those first. So what I'm going to do is leave this one alone, leave this, leave that. I'm going to move this to the bottom and that one to the top. And when I do, that's what I get. So when you get to your final answer, you should have no negative exponents in your final answer. But not only that, you shouldn't have any letters listed more than once. Last two examples to close this section out. So on this one, the 2 stays here. A7 comes to the bottom. B9 stays in the top. A3 stays in the bottom. B5 stays in the bottom. But B9 over B5, that cancels. These are B's, not 6s. I know they look like 6s. So that B5 and B9 will leave B4 in the top because there's more in the top. A7, A3 multiplying is A10 in the bottom. Notice the answer doesn't have any negative exponents. And notice that there's no letter listed more than once. Okay, now let's look at this one right here. Let me uncover this first line. So here we go. This one goes to the bottom. This one stays in the top. It doesn't matter where, no, I'm sorry. This one goes to the bottom too. This one stays in the top. This one goes to the bottom. Doesn't matter where you put it. This one goes to the top. This one goes to the top. This one stays in the bottom. This one goes to the top. The order you write them in doesn't matter. But when I do write my final answer, I usually put them in alphabetical order. All right. Now, look right here. A8, A8. You can cancel those and it leaves no A's at all. B2, B6 leaves B4 in the top. C1, C4 leaves C3 in the bottom. Do that one more time. 3 squared is 9. 2 to the third is 8. A8, A8, all the A's are gone. B2, B6 leaves B4. C1, C4 leaves C3 in the bottom. You have no negative exponents left, and no letter is listed more than once. So this concludes section 5.1. In section 5.2, we have one more exponent rule to cover, but this concludes this video on 5.1.